This lab consists of 4 separate but related activities. We're going to mostly follow the lab write-up, but not exactly. So we'll try to narrate this in such a way as to make it all make sense. Our first activity is going to be involving copper sulfate and changes in copper ion complexes. These are our relevant equations from the lab. So Heather's starting with the 0.1 molar copper sulfate. She's going to add some to a test tube, counting out the drops. As you can see, that's a really pale blue. Hardly any color visible at all at this point. Now she's going to add ammonium hydroxide. Now this solution was just made. Its concentration is as correct as we can make it. However, this material is inherently difficult to get an accurate concentration on, just like sodium hydroxide, because of side reactions that occur with water. So the results may be a bit of a surprise. Here comes our drops. Entering into the third color change. Heather is satisfied with this color. I counted 13 drops. How many did you count? Now make your prediction. One molar hydrochloric acid. Hydrochloric acid is another substance that's very difficult to get an accurate concentration of, and for many of the same reasons. It's usually more accurate than the ammonium hydroxide, however, which isn't even accurate out of a container, being rather marketed in a range of concentration. Almost there. My count was 9, but irrespective of the exact percentages, we clearly see that the effect is real. Let's do a quick comparison. Our sample on the left, a new sample on the right. The colors are comparable. Now let's look at a pH buffer system. A pH buffer consists of two chemicals that are related and are different only because one of them has one more hydrogen ion than the other. H2PO4 has more hydrogen than HPO4. We'll see how that works. So here's our buffer. Those two forms are in that bottle together. An approximate measure is good enough. Now as a comparison, water. Now the calculated pH of our buffer, for what it's worth, is approximately 7.4. This indicator is very sensitive right around pH 7. So the two colors are not exactly the same, but they're close. So now Heather is going to add the 1 molar hydrochloric acid to this solution. Or I should say to these two test tubes. So predict the change. One drop in each tube. Now Heather's going to give each tube a little bit of a shake. The tube of buffer did change, but not nearly as much as the tube of water. So clearly the buffer resisted the change. Now let's look at some other common ion effects. So if you've already looked at the equilibrium lab, you recognize these chemicals, or at least you recognize that they're very similar to other chemicals. This ferric chloride, of course, contains ferric ion. And sodium thiocyanate is very much like potassium thiocyanate. The sodium and potassium really doesn't matter here. So we get much the same color change as you see in the equilibrium lab. mix the sample. Now remember, these pipettes are graduated. The stem of the pipette holds almost exactly 1 milliliter. You'll notice that Heather's using that as a guide. Predict those color changes now. So we're going to disturb the equilibrium by adding a little bit more iron. And this is the thiocyanate again. And now for something different. Yep. Saturated sodium chloride. So keep in mind, this is at least 5 molar chloride, quite concentrated. In our next experiment, we'll do something with something even more concentrated than this. This final segment is mostly about temperature, but we're going to make some concentrated cobalt tetrachloride as a standard for comparison, and we're going to do that by using hydrochloric acid in its full concentrated strength. It's quite dangerous, and we'll explain that as we go along here. So first, the cobalt chloride. As you saw, it's kind of pinkish, reddish perhaps. Now the hydrochloric acid. This is extremely dangerous material. Take it seriously. But remember, it's 12 molar strength, which means it's 12 molar in chloride. So compare that to what you saw when you saw the saturated sodium chloride. We have pushed the cobalt equilibrium as far as it can go. Now we'll set up cobalt chloride for the temperature series. The exact amount isn't really important this time. We have our little ice water bath. Now we'll go to the boiling water. Now this is going to take some time. So we're going to skip ahead and do a comparison. You can plainly see there is a color difference. And that's it.